Okay. At half equivalence, that means half of the Callie and Dustin, y'all could go in there if you need to. Okay. Dustin, you can go in there if you need to, or you can finish 7. Thank you, dear. At half equivalence, half of that acid has turned into conjugate base. Everybody agreed, right? Okay, so that means this and this are equal to each other. Agreed? That means this ratio is 1. Log of 1 is 0. So and I had y'all write that down somewhere. At half equivalence, pH is equal to pKa. Since I already gave you the x coordinate for that point on the graph, I wouldn't mess around. I'd go ahead and do this. The Ka is, oh, we got it here. Oh, well, shoot, we got pKa. Sarah Craig's going to watch this video and go, oh my God. We hope you feel better, Sarah. She's got the flu, y'all. She emailed me last night. Everybody tell Sarah we hope she feels better. We're recording. We love you, Sarah. Okay, so there's that point. For our third point, my national board video. Oh my God. Oh man. I think it's a sinus infection, drainage and stuff. All right, so for our third point, we have 25 milliliters of hydroxide added to our stuff, our acid. Okay, so let's think about what that means. Think about our beaker of acid. We have no more acid, All we have is base, right? So we're going to have to do a stoichiometry here. And I need another way to record. And Linus was supposed to come see me. Yeah. Anyway. All right, so what we got going on, the lactic acid is going to react with a hydroxide. And what's it going to form? Well, it's going to form water. What's the other thing that's going to form? The Na, the sodium is, spectator, so it's going to be this conjugate base, right? Okay, so initially we had 0.1 molar of 25 mils of acid. We had 2.5 millimoles starting out. And at 25 milliliters of base, and it's also 0.1, that's convenient, that's 2.5 millimoles. Okay, initially we have none of that conjugate base. It reacts. How much conjugate base is going to form? 2.5 millimoles. So after this reaction's over, we have none of that. No acid, no of the titrant. That's what equivalence point is. All of your titrant has completely reacted with all of your analyte. All your acid has reacted with your base. Now, since this was weak, we have a conjugate base to deal with, right?
Only 2.5 millimoles be, you didn't put it in
Millimoles. I would divide that by, well, that'd be what, 0.025 liters, right? So it'd be 0.025 liters times 0.1 molar. That would be 0.0025 moles. Okay. All right, so we're going to have 2.5 millimoles of conjugate base, right? Okay. So now we have to think about the equilibrium. In that beaker, we have C3H5O3. What's it going to do? Any base is going to react with water There's our base. This is our acid, right? So it's going to reform our lactic acid. We start out with 2.5. Remember, on equilibrium, you got to have molarity. Okay, so we got 2.5 millimoles of this stuff, this conjugate base, and it is being, it's in a total of what, 50 milliliters? So we have 0.05 molar. Y'all check me. Okay, so we're starting out with 0.05 molar. None of that, none of that. Shifts. So at equilibrium, we'll have 0.5 minus X, and X. So then, this is KB.
So we have to use KW to get the.
Okay. So KW equals KA times KV. 1.38 times 10 to the minus 4th times KB equals 1 times 10 to the negative 14th for KW. So KB .25 times 10 to the negative 11th. Put that in the equilibrium expression. 7.25 times 10 to the negative 11th. And what do we got? We got x squared over 0.5 minus x. Do assumption. X .02 times 10 to the negative 6 That's within 5% rule it checks. What is this? This is not proton. That's hydroxide. It's been what, 2 weeks since we've done this. And we didn't do a lot of it. At equivalence point, your pH, when you're dealing with a weak acid titration, you're dealing with a conjugate base. Remember, that conjugate base is going to elevate that equivalence point pH just a little bit. Remember? So we're dealing with base here. So this is hydroxide. You did not get that. You mean when you punched it in? Okay. I probably hit something in wrong. That's what I got. I don't know. Let me see if I get the wrong answer. POH. .22. So 14 minus 5.22. That sounds wrong. 8.78. Well, I guess maybe not. Let's see. What does the back of the book say? At 25 mils, 8.28. What did I do wrong? Okay, you did not get that, Sarah, for hydroxide concentration.
No, I got 1.90 times 10 to the negative 6.
Right. Did you not do it this way?
No, I did.
You did?
That's why I'm not understanding how we got different answers.
I don't know. Sadie, you said you got what I got? Anyone else got anything same or different? You did exactly this.
Yes, but
You got 6.02 times 10 to the negative 6. And you got what?
for the square root and everything.
For the square root, yeah.
I got 1.90 times 10 to the negative 6. And when I plugged it in to the negative log, I got 5.72. When I subtracted by 14, I got 8.28.
Okay.
Better look.
Did you get this right here? 7.25 times 10 to the minus 11 equals x squared over 0.5.
What?
Did this part right here, Sarah, do you agree with that?
Yeah, that's fine.
Excuse me. Sarah, we're working number 57 in chapter 15, and I'll go to the smart board in just a second. Be patient. We'll give this to you when you get back. Okay, so we multiply by 0.5, right? And then we take...
Wait. It's 0.05. That's where you're doing
Crap.
wrong.
Where did I get 0.5?
I don't know. But we figured out the wrong answer first.
2.5 millimoles, and we got a total volume of 50 milliliters, right?
Yeah.
2.5 millimoles
Divided by 50.
divided by 50 is freaking 0.05.
I don't know if I put my name on the other one.
I wrote it on there for you.
Okay.
You done? Yay, thank you very much, sir. Okay, you have a dummy for a teacher. I'm very sorry about that.
I wonder if I would get
Oh, God, I don't know. Okay, is everybody okay? Dumb teacher did not get the molarity correct. 2.5 millimoles divided by 50 milliliters is 0.05 molar. So at equilibrium, we're going to have 0.05 molar minus X. Now we can move on with life. Thank you, Sarah. Jeez, I can't believe some of the stuff I do. Everyone else who got the same answer as me, are y'all good? Okay, that's the important thing. All right, so let's try this puppy again.
an egg, like, square root of x times 1.
One 1.9 times 10 to the minus 6. Jeez, I'm so sorry, y'all. Y'all just need to put me out pasture. I'm done. Okay, we cool with that. Make sure you're okay with this, guys. Andy, you okay? And I've been doing this for, well, when I kind of sort of knew what I was doing for a good 11 years now. Didn't really know what I was doing in college. It's easy to make mistakes when you're not 100% focused on what you're doing, is what I'm trying to get at. You have got to be hyper-focused on May 2nd. If you get distracted, you're going to make mistakes. I make mistakes for that very reason. We're all human. All right, 5.72. All right, now we agree with Sarah, right? Good deal. And that would be 8.28. So plotting this stinking graph. All right, so our first data point is going to be our X is our volume, milliliters of hydroxide, right? And our Y coordinate is going to be pH. Our first one's going to be 0 and 2.43. Second point is going to be 12.50. I'm just making me a quick table. And pH of 3.86. And then our next coordinate, X coordinate's 25. And Y coordinate is 8.28. Okay. I'm not gonna, you're gonna have to forgive me. Let's see, 0, 250. We'll do 25 there. We gotta do 12. Okay, if I make that 0.12, make that 0.25, and then do say if I do that a pH of 1, 2, that's going to be too short. I don't like it, but I'm in a hurry.
I can do it by twos. for my
Get it by
milliliters.
2s.
For milliliters, you know, pH, I just did 1, 2, 3, 4. If you want to do it this one, you can do it by 4.
Well, yeah, I'm going to do pH by 2s and try to get it spread out, but I don't want to, we got to move on. So mine's going to look a little sloppy. You'll have to forgive that. If I were doing this, to be graded, me, I would obviously try to take a little bit more care with it. But I'm just thinking about our time. Okay, so our first data point is 0 and 2.43. So roughly about there. And then 12 and a half for me would be right about there. And 3.86 right about there. And then 25, I've got marked here, and 8.28. Okay, so this is weak, so it should have a tail, right? And there's our jump. Our jump's not quite as vertical, and then it should start to level off. What does it do from here on out? This is the equivalence point. So after you keep emptying that burette of hydroxide into the beaker, what's going to happen to the pH? It's going to what? It's going to go up to 14, isn't it? So you need to try to show us kind of a curve there. Remember, weak acid does not look like, doesn't have that big S look and actually you should show it start leveling off a little bit. You always should show a pH curve is leveling off somewhere. But if you're not given this much extra data, you can't really be expected to go that far past the equivalence point. You got to know where it's going, but just show that it's going up. Okay, we're going to switch to the smart board, and we're going to talk about ASP. Let's take a look at number 75. I want to look at 75B. That's the assignment yesterday. Oh, that's okay. Just kind of watch with us there. Okay. This is solubility equilibrium. After acid base in chapter 15, this is the last thing we're going to do with equilibrium. Number 75 was assigned yesterday. I want to work 75B to show you about number of ions. So on 75B, we've got bismuth iodide. Okay, the problem says calculate KSP for this solid. Well, the very first thing you got to have is your dissociation equation, because you need it for the equilibrium expression, which you need to figure out KSP, your equilibrium constant, right? So step one, get your dissociation. How is this going to break apart? It's ionic.
The 3 plus was 3.
Awesome. Very good. So when we put this stuff in water, and those water molecules come in, they're going to pull 1 bismuth and 3 iodide ions off the crystal lattice for every mole of this solid, right? Okay. So our equilibrium expression, that's the second thing you need. Equilibrium expression. Remember, SP just means solubility product. That's what we call this thing. Solubility product is what we're calling K. We do not put solids in an equilibrium expression, so this would simply be what? Good. And iodide. Good. Okay.
You said that it would be 3 ions.
I'm not there yet, Sadie. When you write the equilibrium expression, you write it this way. We have not done this since gases chapter. We have not done since chapter 13. Okay? Because all we've dealt with in chapter 14 and chapter 15 has been monoprotic acids, and we haven't had to do any funny stuff with X since chapter 13. But I'm hoping this will jog your memory. This is the equilibrium expression, agree? It's simply, this is a shorthand that says that the equilibrium expression is the concentration of bismuth raised to the first power times the concentration of iodide to the third power. So just bear with me a second, okay? Okay. Look at the way the problem's worded. It says the solubility of this stuff is 1.32 times 10 to the minus 5th. Solubility is X. Okay? Notice the unit, it's molarity, it's moles per liter. So, to get our KSP, we're going to have what? Now, in your book, they go through and do the whole equilibrium shift, the Rice chart, but we don't really need that. That thing, it's just a solid, so it's not going to affect this at all. If it starts out solid, it's got to shift to the right. Agree? So we're going to have what for bismuth? X. What are we going to have for iodine? Look at the stoichiometry. 3X. Remember, we have not done that since chapter 13. 3 times as many iodide ions are going to come out as bismuth ions. Y'all get it? Okay, cool. So this is going to be X for bismuth, and it's going to be 3X cubed for iodide. Remember, we haven't looked at this since chapter 13 in a long time. Okay, so KSP is going to be what? What? X times 9X cubed? Oh, wait, no. 3 times 3 is 9. 27. 27X cubed. That would be X to the 4th. Okay. that is 27, x cubed and x is x. Lord, y'all check me. No?
I don't understand where you're getting the 27 at.
You gotta do 3 cubed.
Times 3.
3 times 3 is 9, times 3 is 27. Okay. Cool, Sadie?
Yeah.
Huh?
Is it okay if I don't do it like that though?
Yeah, as long as you get it. Okay, so we got 27x to the 4th. So that's what? 27 times, what was our solubility? 1.32? Negative 10. Y'all forgive me on that.
Well, she just cubed the 3 before she did anything else.
It's what?
Like the 2x together.
But step the 4 still.
You still do that?
Yes, Erin, I'm sorry. Log and all this other stuff.
I probably would have done like that if I was in the computer just because it's
Somebody check for that in the book, please.
It's 8.12 is negative 19. So all we did, we did.
This stuff's not hard. It's just that we have not dealt with doing the things with X for a long time. Now, with the acid base, it's been monoprotic, we just had X. Okay, now, what about the reverse? What if we are given the KSP and are asked to find the solubility? Not a big deal, it's just reverse engineering, right? Let's try that. Y'all take a look at, and this would be like sample exercise 14 or 15 in your book, if you need to revisit. This is like sample exercise 14 on page 755. So if you need to go back and kind of spend a little time with it, go back and study that problem. All right, let's try number 79. No, wait, let's do number 80. Number 80A. Number 80A.
I'm with her right now.
Huh?
I'm with her.
Right now. Right now. Chapter 15, page 777. All right, so it says it wants us to calculate the solubility of this substance in moles per liter. Ignore any acid-base properties, has to do with what I want to do, which we'll have to do tomorrow, and that's okay. We'll do it tomorrow. That pH curve kind of ate up some time. PBI2, looking for solubility. You still need the equilibrium expression, which means you need the dissociation equation. So what is the equation? Okay, so KSP is going to be PB and iodide squared, right? So it tells us the solubility is 1.4. This number, KSP, is 1.4 times 10 to the minus 8. Thank you. And this PB is going to be what? X. Look at your stoichiometry. If it helps you, pause for a moment, go back to your equation, and think about stoic. When this thing breaks apart, what's it going to break into? One little old lead ion, right? X. And how many big old iodides? Are y'all good or y'all bored? Because if you're bored, you can tell me. It won't hurt my feelings. We'll move on. Okay? I'm not getting on you. I'm just being real. Okay. All right. Because I don't want to waste your time. We ain't got time to waste. Okay, so for PB, we're going to insert X. And for I, it's going to be 2X, right? Okay, let's simplify this. So that's going to be 4X cubed, right? Y'all check me.
That's what I got.
All right, here we go. This ain't bad. We're used to this kind of math. X equals our solubility. So we're going to take that, divide it by 4, and take cubed root.
She got 4 because she took the square root of 2.
The square root?
Not the square root. She took the power of 2.
How did she get square root? They're not the other one.
She took 3 to the third power. 3 to the second power.
How did she do it? Because she could add like 1 on it and then put the 3 of them out and then 3
But you have to take the x to the power.
All right, y'all check me. These sig figs too.
Yeah, how do you keep
Oh, I go to math, arrow down, and select cube root.
Or you can do it with a 1/3.
Yeah, or you can do rooftop to the 1/3 power. (1.5) times 10 to the -3rd. Solubility, you have to put the unit molar. Solubility is moles per liter. Solubility is a concentration, okay, y'all?
You didn't put the 10.
Oh. I would like for you to please, let's do this. Let's do 77, 78, and 79, just to make sure we get a handle on this stuff. Okay. We have, now, before you leave, give me 10 seconds of your time. We now have 18 and a half days left of discussion time before the exam. Now, I'm not including our practice exam on Thursday before the exam. I'm going to give you some extra practice. I would like for you to come to tutoring 7:30. If you don't come to tutoring, you'll have to do this work on your own time. Okay? At 7:30, I'm going to have a pre-response review. It's going to be thermokinetics, gases, stoic, electrochem, equilibrium. We're going to practice. Okay? So if I can ask you to just get up here a little earlier for 14 days, because you can't do it on Mondays, because I know you won't have time after school. Okay? Okay. Have a good day.
Get my big butt out of bed.
I'm not too good to see that on the wall.